In this Leetcode problem, we were tasked to count how many bits of 1 a number has. For example, 12 is written 1100 in binary, and it has 2 ones. This Leetcode exercise wants us to determine how many ones a number has. Simple, right? Now let us be reminded of a couple of terminologies related to computer architecture, because this exercise requires us to know how to manipulate bits. Left shift. If I say 12, left shift by 1 bit, that means I am moving the number by 1 bit to the left, basically multiplying it by 2. Right shift. If I say 12, right shift 1 bit, that means I am moving the number by 1 to the right, basically dividing by 2. Bitwise AND. With AND, only you'll get 1 when both operands are 1, otherwise 0. Bitwise OR. With OR, you'll get 0 when both operands are 0, otherwise 1. We'll be needing those 4 concepts shown on the screen to be able to solve this problem. Let us take 12 in binary. If my goal is to count how many ones there is, I'm going to need first a variable to store the count and a loop to iterate a certain amount of time. At each iteration, I want to get the least significant bit of our number and check if it is a 1. To do that, if I say n bitwise AND with 1, this will result for me 0. That is the least significant bit, or LSB, of my number. I'm going to check if it is 1. I will increment it by 1. In our case, it is not, so we will ignore it. Now, what I need to do is right shift n by 1 bit. Look what will happen. We basically remove the LSB, and we will get this binary format, which is 6. So we simply divided the number by 2. Why I did that? Because I want to iterate over the whole binary sequence that I have. So that means you can see at each iteration, the number is decreasing, while the number n is decreasing at each iteration, because I am doing right shift to be able to get every bit of the sequence and to be able to check if it is a 1, which will allow me to increment count by 1. You can see that we will arrive to a point where n is equal to 0, and we still need a condition for our loop. So this will be my condition. As long as n is greater than 0, then I want to perform the following. Otherwise, I'm going to return count. And that is it. Simple enough. Let's go ahead and write this in code. Alright, to start, I'm going to create 2 variables. The first variable is going to be the count variable to count the number of ones in my binary number. The second variable will store the least significant bit, which is the last bit in a binary sequence. Alright, so I'm going to call it LSB, and I will set it at first equal to 0. Now, I will be needing a loop, so I'm going to say while, and the condition, we will specify it during the process. So now, what do we want to do first? First thing, I want to get the least significant bit, so I'm going to store it inside LSB. Now, how I'm going to get the least significant bit of my number? Well, if I say n, which is my number, bitwise AND with 1, this will get me the least significant bit of my number. So let's consider that our number is 11. This is its binary format or representation. The least significant bit that we will get is 1. So if I try to AND this in front of you right now, let's go ahead and see what will happen. So if I AND it with 0, 0, 1, this is the binary representation of 1. Now, if I'm going to do AND, let's say now 1 and 1 will give 1. 0 and 1 will give 0. 0 and 0 will give 0. And 0 and 1 will give 0. So this is the number 1. So our least significant bit is 1. So LSB now stores 1. Alright? Now what do we want to do after this? What I want to do is I want to check if this LSB is equal to 1. So I'm going to say if LSB, a simple if statement, is equal to 1. If this is the case, what I want to do is simply increment counter by 1. And that's all I need to do. Now we still need to do one more thing. So basically, I just checked if this bit is equal to 1. Now it's time to go for the next bits. What I need to do is shift the number to the right by 1 bit in order to remove this bit. Like this, we'll get this new sequence or this new binary representation. This number is 5. So what I'm going to do is I need to left shift n by 1. So I'm going to keep it simple. I'm going to say n equal to n right shift by 1 bit. Like this, we right shift n by 1 bit, so we could get this binary sequence and we could continue our iteration. So now what will be our condition? If I continue to right shift n by 1 bit, In the end, I'll get nothing, I'll get 0. So, my condition will be the following. If n, or as long as n is greater than 0, I want to do the following. And this is our code. At the end, when you exit the while loop, just simply return count, like this. Alright, let's go ahead and try this out. As you can see, after running my code, 11 has 3 ones of bits. Now, if I go ahead and try 12, we should get 2 only. So I'm going to compile and then launch. We got 2. Let's try, for example, 1. It should give us only 1. So I'm going to say compile first and launch. It will give us 1. And there you have it. Thank you for watching this video. I hope you enjoyed. Make sure to subscribe and I will see you in the next video.